Hello everyone, welcome to Chemazon-Complete Chemistry. In our today's video, we are going to learn how do we actually prepare a solution in a chemistry lab. So here is an activity that is given to us that we have to prepare 100 ml of 1 molar solution of potassium permanganate or KMnO4. What is given to us is molar mass of KMnO4 is given to us, which is 158 grams per mole. So for that we have to do some calculations. We have to calculate the mass of the KMnO4 that we have to use. Okay, we have to find out the mass of the KMnO4 that is to be weighed using a machine called as weighing balance, electronic weighing balance. So for that, let us write down the formula for molarity that we had seen in the last video. What is molarity? Molarity is number of moles of solute. What is the solute here? What is solute? Solute is a substance that is present in less amount, or component of a solution which is present in less amount. Here what is our solute? Our solute is KMnO4 divided by volume of the solution in liter. Volume of the solution in liter. So first let us calculate the volume of the solution in liter. What is the volume we have to prepare? It is 100 ml. Okay, what is 1 ml? Milli means 10 raised to minus 3. So milliliter means 10 raised to minus 3 liter. If we solve this, we will get 0.1 liter. So we got the volume of the solution in liter. Okay, now we can calculate the moles of KMnO4. How do we calculate the moles of KMnO4? By using the above formula. Molarity is 1 molar. What is unit of molarity? It is mole per liter into what is the volume we just found out? It is 0.1 liter. So this comes out to be 0.1 moles. Right? Units gets cancelled. Liter inverse and liter gets cancelled. What is left is mole. That is 0.1 mole is present. And how do we calculate the moles of mass of KMnO4 now? What is moles of any substance? Moles is given mass of that substance in gram divided by its molar mass, which is in grams per mole. Or I can write this as like this. So what is the mass that we have to calculate, which will be how many moles is present? 0.1 mole is present into what is the molar mass that is given? 158.0 gram per mole. So here again we can see mole and mole inverse gets cancelled, and 158 into 0.1 will be 15.8 grams. So this is the total amount of KMnO4 that we have to weigh to prepare this 100 ml of 1 molar KMnO4 solution. So now let us see actually how we will prepare in the lab. What are the steps that is to be followed? So first of all, these are the apparatus that is required. This is the weighing balance. Okay, the electronic weighing balance that I was talking about. Okay, beaker containing distilled water so that we can do the dilution, or we can add the solvent. Solvent here is water. This is called as standard volumetric flask. What is the use of this? Why we are specially using this flask is standard means it is calibrated, which means there is a fixed marking on every volumetric flask, and this is a 250 ml flask, but we need only 100 ml. So we will take 100 ml of volumetric flask and KMnO4, so that this is nothing but a solid compound, right? It is a purple colored solid compound, reddish purple you can say, and this is the wash bottle. Okay, this contains normal water, or we can add distilled water, and then obviously pen for doing the calculations. So these are the apparatus that we will require for preparing our solution. So what is the first step? First step is we have to weigh how much we had calculated. 15.8 grams of KMnO4 we have to weigh. So we will weigh 15.8 grams of KMnO4 first. Second is we have to carefully transfer the, here you can see it is purple colored compound, this is potassium permanganate. We have to carefully, very carefully transfer the compound, not like this. Another better way is to use a glass funnel. Okay, this is a proper method to use a glass funnel, which is more safer, dry glass funnel, so that none of the particles are fallen out from the weighing paper. And next step is add a little amount of water such that all of the KMnO4 dissolves. Dissolving the KMnO4 is very, very important to get the correct concentration. So after adding some amount of water, we have to swirl it vigorously. What we have to do, swirl or shake the volumetric flask, uh, not too vigorously such that the solution comes out of the volumetric flask, but it should be enough so that the compound gets dissolved, that is KMnO4 gets dissolved. And then we perform the dilution. What we are adding? We are adding the solvent, that is the water, up to the mark. Okay, there is some mark up to which we have to add. Okay, this is the mark that I was talking about. This white line you can see, this is the mark which is already provided in the volumetric flask. And to add a small last 1 or 2 drops, you can use this wash bottle, or another better equipment would be a pipette. So in this way we can prepare our solution. So that's it for the today's video. We learned how do we exactly prepare a solution having a fixed molar concentration. Now in the next video what we are going to do is we are going to see how do we perform serial dilution from a stock solution. Means now we don't have the solid compound, now we will be having already prepared higher concentration solution. From that we have to prepare lower concentration solutions, series of lower concentration solutions. That is why it is called as serial dilution. We will see about this in much detail in the next video. Thank you.